This next section is about logs and how to evaluate and how to expand logs using log properties. So the first part is how to evaluate logs. The thing to remember is that a log is an exponent. I had a coworker once who said log is an abbreviation. It stands for what is the exponent? So if you use the triangle of power, the base always goes in the lower left, and the writing it in exponential form is always on the side of the triangle. So 2 to the third power equals 8. That's exponential form. And that's going to be the side of the triangle. And if I want to rewrite that same relationship as a root, I would say the cube root of 8 is 2. So the answer would be over here because it's not highlighted. So that's when you're writing it in root form or radical form. And then if I want to write in log form, that's going to be the base of the triangle. Notice that the base for log form matches the base for exponential form, and that with log form, the answer is the exponent. That's because logs are exponents. So the bottom part of the triangle says log base 2 of 8 equals 3. We're looking for the exponent of 2 that gives us 8. So here's some to evaluate. We're looking for the exponent of 2 that gives us 32. Or if we wrote it on the triangle, we would say the base is 2, the answer is 32, and we're looking for the exponent. So that's 5, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 gives you 32. Some things to remember about exponents. If I have a to the negative b power, a negative exponent moves it to the other part of the fraction. So that's the same thing as 1 over a to the b. Some other things that you should know about exponents are anything to the 0 power is 1, even though it's not logical, or it is logical actually, but it's not what you immediately think. And then the other thing you should know about exponents is if you have a fractional exponent, then you would write that as a root. The bottom number is the root, and the top number is the exponent. You could also write it like this. It's not wrong, because you can do these in either order. So with those properties of exponents, this one is a square root. So the bottom number becomes a root. With square roots, we usually don't write a 2. So this is going to be 1/2, because 3 to the 1/2 power is the same thing as the square root of 3. This one, it's in the denominator. So the negative exponent turns it into a fraction. And then it's not a 5, it's a 25. So we want it to be a negative 2. This one is saying the base is 7. The answer is 7. What's the exponent? It's got to be 1. And this one, the base is 4. The answer is 1. What's the exponent? And that's using this property right here. So the answer is 0. Another thing you should know about logs and exponentials is that they undo each other. So if I do log base 3 of 3 my answer is just going to be the exponent. If I raise 2 to the power of log base 2, my answer will just be 11 here. Some logs, we don't write the base because they're so prevalent. A natural log is a log with a base of e, and that button is on your calculator. So that's why these ones are important, because you can find them on your calculator. A common log is going to be base 10, and that button is on your calculator. Notice how both of these buttons share space with their opposite. They share space with the exponential that undoes them. So if we're evaluating log of 100, remember that means our base is 10, our answer is 100, and we're looking for the exponent. E to the and natural log are going to undo each other, so that's going to be 2 as well. And then this one is a kind of tricky, but it might be helpful to write this as a fraction. I have 3 zeros, so that means it's 1 over 10,000. And so the exponent for 10 that gives me 1 over 10,000 is going to be negative, and then I count the zeros and say it would be -4. Here, natural log and e to the undo each other, so I just have 5. And here, 10 and log 10 undo each other, so I have 100,000. The next section is about rewriting logs using log properties. The way we use log properties, there are 3 of them. If I'm adding, if I add exponents, that's because I was multiplying. So when I'm doing this multiplication property for logs, it's because logs are exponents. We add exponents when we're multiplying. Same thing for division. We subtract exponents when we're dividing, so that's why that division turns into a subtraction. And this is the most important property of logs. It's why we love logs. It's because they can help us bring an exponent down from its highfalutin place. If you have log of a to the b, you can bring the b down in front. Okay. So if I want to write as a single logarithm using these log properties, I know I'm done when I only have the word log once. So the first thing I see is that kind of following order of operations, I have some 2 times, 3 times, and 4 times. So that's going to be this property. Using that property, this becomes log of x squared minus 3 log of, oh, not 3, I can bring that up as an exponent, right? So log of y cubed, and then log of z to the 4th. Okay. Now I'm going to follow log properties. I'm going to follow order of operations. Addition and subtraction are equivalent, so I start from left to right. So I'm going to do this first. That becomes log of x squared over y cubed plus log of z to the 4th. And then this is addition, so I'm going to multiply. So that becomes log of x squared y cubed times z to the 4th. Another way, a cleaner way of writing that would be log of x squared z to the 4th over y cubed. I'm done now because I have a single log and I have compressed it. If I want to expand using log properties, then I'm doing the opposite, and I know I'm done when all of my logs are just simple, totally simple. So here, I kind of do the order of operations differently. I say, okay, when I squint at this, it looks like division. So I'm going to do division. I'm going to say this is log of a to the 5th. Sorry, I'm going to pause for a second. I have a timer going off. Be log of a to the 5th minus all of this, log of b squared cube root of c. And I can split this up because when I squint at this, it looks like multiplication. So log of a to the 5th minus log of b squared plus log of, and I'm going to write this as an exponent because it's a root, so it's the same thing as c to the 1/3. Notice how this negative applies to the entire denominator. We're dividing by the entire denominator, so we would like to group that. Or if we want to, we can distribute the negative through. But we still have another log property to deal with. We have this one where we have exponents, so we're going to bring that down. So it's going to be 5 log a. I'm going to go ahead and distribute the negative, but you can leave it with parentheses if you want to. Oh, I forgot to put the 2 out in front. And then, oh, not plus, because I'm distributing the negative, so it's going to be minus. The c to the 1/3 is in the denominator, so we need that to be minus. And now I have made my logs very simple. Everyone is just a log of a simple thing. So I know I'm done, and that is expanded. The last log property is a change of base property. The way you change base is you can write a log in any base by turning it into a fraction of logs. The base goes in the basement when you do this. And it really can be any log. The reason I have common logs and natural logs written here is because those are the ones that you have buttons for on your calculator. So those are the most common ones we want to use for change of base. So rewrite in terms of natural log, the base goes in the basement. So I'm going to write natural log of 7 and then natural log of 20. Here the 20 is the base goes in the basement. So this one would be natural log of 20 and natural log of 7. If I grab my calculator, I can see that natural log of 20 divided by natural log of 7 is 1.5. Oh, the next number over is a 5. So if I'm going to 3 places to the right of the decimal, I would want to write this as 40. So I'm going up. And then here, oh, same thing. The last number is a 5. So this would round to 0.650. It kind of makes sense that this number is bigger than 1 because we're saying 7 to the 1.540 is 20. This is rounded, so it's not exact, but 7 to the 1.540 is approximately 20. So it makes sense that this exponent is bigger than 1 because 20 is bigger than 7. And here it makes sense that this exponent is smaller than 1 because we want to get a number that is smaller than 20 to come out of an exponent. All right, that is an introduction to logs. Thank you so much. Bye.